Network scanning concepts. At its core, network scanning is about mapping out a network, like using sonar to understand the underwater landscape, revealing hidden structures and depths. It's the process of identifying live hosts, open ports, and vulnerable services. One key concept is active scanning, where we directly send packets to a target and analyze their responses. This provides immediate feedback but can be detected by security systems. It's like knocking on every door to see who's home. Conversely, passive scanning involves monitoring network traffic without sending any packets ourselves. This is stealthier, akin to listening to conversations to gather information without being noticed, but provides less comprehensive data. Understanding these foundational concepts is crucial for both offensive and defensive cybersecurity operations. They lay the groundwork for identifying potential attack surfaces or ensuring network security. Scanning tools. These are the digital instruments that help us discover devices and services on a network, much like a mechanic uses specialized tools to diagnose a car's issues. They automate the process of sending probes and interpreting responses. Tools vary widely, from command line utilities like Nmap, renowned for its versatility and power, to graphical user interfaces that simplify complex scans. Each tool has its strengths, whether it's speed, stealth, or the depth of information it can gather. Some tools focus on specific aspects, like vulnerability scanners that look for known weaknesses, while others are comprehensive, offering capabilities for host discovery, port scanning, and even OS detection. Choosing the right tool depends on the objective of the scan. Now, let's see one of the most powerful scanning tools in action, Nmap. We'll use it to identify services and their versions on a specific host. We use Nmap with the SV flag, followed by the target IP address. This command instructs Nmap to attempt to determine service versions on open ports. The result shows us the port numbers, their state, the service running on them, and importantly, the version of that service. For example, we can see SSH and HTTP services with their respective versions. This information is invaluable for both attackers, who can identify vulnerable software, and defenders, who can ensure all services are patched and up to date. Knowing your tools is key to effective network security. Host discovery. The goal here is simple. Find which hosts are alive on the network. It's like walking through a neighborhood and knocking on doors, waiting to see who answers. In networks, we don't use hands, we use packets. The most basic method is the ICMP echo request, commonly called a ping. If the target replies, it's alive and reachable. But in many environments, ICMP is blocked by firewalls, leaving us blind. So we turn to TCP or UDP probes. Instead of asking directly, we try to connect to services like HTTP or DNS. A response means the host is active, even if ping is blocked. And on local networks, ERP scanning is highly effective. It sends out, "Who has this IP?" and devices are required to reply with their MAC address. These techniques allow attackers to map the network and help defenders to track assets, detect intruders, and monitor unknown devices. Now practically, let's find live hosts in the 192.168.1.0/24 subnet. We'll use Nmap, a trusted CLI tool for both attackers and security professionals. To do this, we type Nmap SN followed by the target subnet. This instructs Nmap to perform a ping sweep without scanning any ports. The result? Nmap identifies 4 live machines, each showing an IP address and a MAC address. This step is crucial. It gives attackers a map of reachable targets and provides defenders with visibility into their network. Whether you're preparing an attack or verifying your infrastructure, host discovery is always step 1. Port and service discovery. This concept is about identifying which doors are open on a network device and what services are running behind them. Think of a building with many doors. We're trying to find out which ones are unlocked and what kind of office or shop is inside. We achieve this by attempting to connect to various ports on a target host. An open port indicates that a service is actively listening for connections on that specific port number. This tells us what network functions the device is offering. Understanding these open ports and the services they host is critical. It allows us to identify potential entry points for attackers or verify that only intended services are exposed on a system, adhering to the principle of least privilege. Now, let's practically discover open ports on a target host using Nmap. We'll use Nmap with the P flag, followed by the target IP address. This command tells Nmap to scan all 65,535 possible ports on the target. The output provides a clear list of open ports, along with the associated service. For instance, we might see port 22 open for SSH, 80 for HTTP, and 443 for HTTPS. This detailed information helps attackers find potential weaknesses, like outdated web servers, and enables defenders to close unnecessary ports and harden their services. This is a foundational step in any comprehensive security assessment. OS discovery. OS discovery is like trying to figure out the make and model of a car just by observing how it drives and responds to signals. In cybersecurity, it's about determining the operating system running on a target device based on its network behavior. This is achieved by analyzing subtle differences in how different operating systems implement network protocols. For instance, various OS versions handle TCP, IP stacks, fragmentation, or initial window sizes uniquely, creating a distinctive fingerprint. Knowing the target's operating system is invaluable. It allows attackers to tailor exploits to specific vulnerabilities, while defenders can verify that their asset inventory is accurate and that all systems are running supported and patched versions of their OS. Let's now demonstrate OS discovery using Nmap. We'll execute the Nmap O command followed by our target's IP address. The O flag instructs Nmap to attempt to detect the operating system. The result often provides the operating system, its version, and sometimes even the kernel version. For example, it might identify a target as Linux 5.x. This information is critical for refining attack strategies or prioritizing patching efforts. Pinpointing the OS helps both sides of the cybersecurity coin, enabling precise targeting for exploits or focused defensive hardening. Scanning beyond IDS and firewall. This topic delves into the art of making your presence less obvious, akin to a chameleon blending into its environment to avoid predators. It's about techniques to bypass or evade intrusion detection systems and firewalls during a scan. One common method is fragmentation, where scan packets are broken into smaller pieces. This can sometimes slip past basic firewalls that don't reassemble fragments before inspection. Another technique involves using decoys, sending packets from multiple fake IP addresses alongside your own to obscure your true origin. Timing is also crucial. Slowing down scans or randomizing delays between probes can prevent signature-based IDS from detecting anomalous activity. These methods are essential for attackers seeking stealth and for defenders testing the resilience of their perimeter defenses. Now, let's see an example of how Nmap can be used to attempt to bypass detection. We'll use Nmap with F for fragmentation and D R&D, 10 to generate 10 random decoy IP addresses. This command attempts to make the scan appear as if it's coming from multiple sources, along with fragmented packets. The output itself might seem ordinary, simply indicating the host is up. However, the significance lies in the method of scanning, which aims to make detection more challenging for security systems. For attackers, these techniques can mean the difference between discovery and success. For defenders, understanding them is vital to configure and tune IDS and firewalls effectively, ensuring they can detect even sophisticated bypass attempts. Network scanning countermeasures. These are the defensive strategies we deploy to protect our networks from being mapped and exploited, much like building a robust fortress with multiple layers of defense to deter invaders. The goal is to detect, prevent, or at least impede unauthorized scanning activities. A primary countermeasure involves implementing strong firewall rules to block unsolicited inbound connections and restrict outbound traffic to only what's necessary. This acts as the first line of defense, filtering out known malicious skin patterns. Intrusion detection systems, or IDS, play a crucial role by monitoring network traffic for suspicious activity, such as port sweeps or unusual packet patterns, and alerting administrators. Rate limiting and honeypots can also divert or trap attackers, gaining intelligence on their tactics without compromising real systems. Ultimately, effective countermeasures combine technical controls with regular auditing and an understanding of attacker methodologies, ensuring your network remains a difficult target for unauthorized reconnaissance.